Hello everybody and welcome to another video, and in this video we're gonna see the application of k-nearest neighbors algorithm on a real-world database. Actually, we are going to use the Boston housing prices database from the 70s, and we're gonna use a lot of features, 10 features in fact. That means we're gonna have 10 features for input, and we're gonna want to predict the median value of homes in thousands of dollars. This is the actual data we're gonna use. You can see here there is no headers, but you can find the headers here, and like what each header means, from crime rate, taxes, I'm sure, yeah, taxes, because these are important, age, and many things, but we are not going to use all of them. We are just going to choose 10 of them, which are the most significantly important. We're gonna see that later. So we're gonna import the matplotlib library, as we did always in our previous videos, the NumPy library, TensorFlow, of course, the requests library. We did it last time, and this is as we saw last time, we give it the path for the data on internet, and it's gonna download it for us. This is the headers that we have, but we are not going to use all of these headers. We're going to use just these headers, and we are going to predict the median value of house pricing. So as you see here, we're going to use the length is just the calls used, or the columns that we're going to use. The housing file we are going to get it using the requests library and giving it this link for the data, which is exactly this one. And yeah, and we're gonna take all the data where from the file we download, and the y values are just the 13th value. That means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is our y values. The x values are all the values except the 13th, and provided that the header exists in calls used. That means these ones. Okay. Then we do the scaling. We saw it last time. Data scaling. This is the min-max scaling, as we saw it last time, and we saw how much important is this one. So we have like a better model. Then we split the data, as we did also last time, split it 80% for training and the rest, which is 20%, for testing. Then we declare the batch size and the k-value. The k-value represents the neighbors that we're gonna see for each data point we provide. So when we provide one data point, we see 4 neighbors, and the majority where these neighbors go, which class they go, we put this data point at this class. We create the placeholders, which is very important for in TensorFlow. You need to create placeholders so we can put our values later, our variables later. Then we calculate the distance. We create our distance function for batch of test points. Here we illustrate the use of L1 distance, the Euclidean distance, or the L1 distance, the mathematical naming for it if you don't know it. We just like calculate the subtraction between our data points and the test data points. We need to expand the dimensions because, for example, you cannot put a matrix minus a vector. We saw that in the first video of this course, if you remember. I remember that. So then we do our prediction. How? We create the prediction function. To do this, we will use the top k. It's provided with the top k function is provided with the TensorFlow framework. You can find it here. Oh, sorry. You can find it there. And this function, which returns the value and indices of the largest value in a tensor. So we get the largest value. Since we want indices for the smallest distance, we will instead find the biggest negative distance. So since we want the smallest one, we just take the biggest negative one. That means the smallest one. We also declare the prediction and the mean square error. We use the mean squared error. I didn't show you that one in the theoretical video, but you know it now. We use the mean squared error to calculate the cost function, if you remember it. So that's actually what we do here. We take our top k values and we do our prediction normally, as we did before. And here we calculate the mean square error by calculating the sum of the square between our prediction and the targets we give. That's why I always tell you that KNN is semi supervised learning. It's not supervised, not totally unsupervised learning. It's semi, with the batch size, of course. And yeah, and then we calculate how many loops we need to do. Actually, I think it's only one loop because we took the, yeah, you don't care about that, but yeah, this is just there for just to be sure. So we enter our loop. We take the mean value multiplied by the batch size. So we take it like batch by batch. And I think it's going to be just one batch. So, but yeah, to be sure. Then the max is just the batch size multiplied by the mean, and we also put the length of the x values for training dataset. So we have the batches for test dataset and the y's for test, so we can test our model, of course. We initialize our predictions by running the session finally. That means now all this code is going to be executed starting from here. We give it the dictionary, so the training data, the placeholders we created here. So the training data, for the x, the test data for the x, and the target for train, and the test for test data, the target for test data. Then we calculate the mean squared error, and so on, so on. Then we print, of course, the mean squared error, so we know. And then here I put after we do all of that, we plot an histogram for the actual target values, comparing them with the predicted values. So we can see the average method, and also we're gonna have a trouble. I'm gonna show you that we're gonna always have a trouble predicting the extreme ends of targets, because always extreme ends, like you will choose kind of far away neighbors, so in like extreme places like the corners and so on. So there's gonna be a problem. Let's run and see how it's going to be. Okay, what's that? Which configuration? There's problem. Let me see where the problem is. It shouldn't be. Let me stop the video and see what the problem is. So now we execute the code, and let's see how it goes. My computer always gets so slow when it comes to recording and executing code at the same time, but we have our results. So as you can see here, as I told you before, uh, mostly our prediction, which are in blue, come exactly as the actual values, but it's harder to do that when it comes to extreme values. So here you can see when it's like 50, that means $50,000. It's like extreme, and this is also extreme, like $5,000 is too small. It comes like a little bit more hard to fit exactly to the prediction values, but as you can see here, it looks pretty well. So yeah, thank you very much. That was our video for nearest neighbor algorithm. And yeah, it was really nice course with you. And I really recommend you to take the next course, which is deep learning, where we're gonna like enhance like to further knowledge. And actually, I'm gonna give you the actual hot topic these days, which is like neural networks and deep learning. I really recommend you to take the course. And even if you don't take the deep learning course, please practice and practice your skills and tackle real world problems as much as possible. It's gonna help you in your like future, your career, anything. So yeah, thank you very much for taking the course, and I hope to see you next time in the deep learning course.